Hello and welcome to PE Academy. So this is example 4 on the video series SuperMesh. So we've looked at 3 other examples. If you missed that, please I'll leave a link to that in the description of this video so you can check that out. So this is a typical question under SuperMesh. So you can see that it's different from some of the ones that we've been looking at in the past, in the sense that we have 4 meshes, and the question itself is asking us to look for what? It says find the current in each meshes and the current passing through each element. So it's a low lot of questions in just one circuit like this that we're asked to look for. So it's a very simple thing, don't let it to confuse you. And if you have been following this video so far, you can just pause it and attempt the question just to test your understanding on what I've been sharing with you so far in this video series on that SuperMesh. Alright, so to start with, let's pick our current direction for each of those meshes. So this is, let me take this to be I1. So let me take the current here to be I1. Also in clockwise direction, this is I2. So let me take this to be I3. And this is I4. So I hope everything here is clear, because I just have only red pen to work with today. Alright, so having done that, I've picked my current direction. The next thing is for us to put our polarities. So for the voltage source is always constant. This is plus and minus. The voltage source is not influenced by these directions that we've picked. It's always constant. So just know that the longer one is positive, the shorter one is negative. So now let's add polarities to the elements we are having in this circuit. And the elements we are having there are just the current source and the resistors. So this is going to be plus and minus. And then this is going to be plus and minus. So in this direction for I3, so this will be plus minus. In this direction, plus minus. Remember, the positive will come first. So in this also, that in this direction, this is going to be plus minus. This will be plus minus, plus and minus. While for this, in this direction, this will be plus minus, plus minus. So we've been able to add polarities to everything. So the next thing we have to do is let's equation of our current source. So let me do that. Equation of our current source. So in doing the equation of the current source, so let's draw the diagram. This is the current source. Remember, super mesh, when there is a current between two meshes, that's when we use super mesh. And this current is what will give us the equation of the current source. So let me just draw it out. So it's going upward. We have 4 amperes here. So there are two currents that is flowing through it. We have I1 and I2. So I1 is flowing in this direction, which is like the downward, and I2 that's like upward. So let me indicate it. This is I1 and this is I2. And if you look at this closely, you see that I2 is flowing in the same direction with the current source. So with that, we are going to be having what? I2 minus I1 equals to what? 4 amperes. And this is our equation 1. Don't forget, I said the reason why I2 is coming first is because it is in the same direction with the current source itself. That means the value of I2 is higher than I1. So once you do all the calculations, you get your I2. If you subtract it from I1, it will definitely give you 4. So you can just test that with some of the previous example, and then you get what I'm saying. Alright, so having done that, so let's draw our SuperMesh circuit. Our SuperMesh circuit is this particular circuit where we are having two meshes and then the current source in between them. So let's do that. So let's draw our SuperMesh circuit. Let me see if this pen are working well. So let's draw our SuperMesh circuit. So let's draw a SuperMesh circuit. So that CKT is just my own abbreviation of circuit. Alright. Okay, so they are still not working. Alright, so let's just continue. So it's going to look like this. And don't forget, like I said, if you are drawing your SuperMesh circuit, you omit the current source, and then whatever element is that is on that particular branch. So it's going to be looking like this. Here we are having 4 ohms. Here we are having 8, and this is 6, and this is 2. So let's add the polarities. So this is still plus and minus. and in this direction, because of current I1, this is plus minus in this direction in clockwise. When it is going clockwise, when it gets here, it is straight. And then this is I2. Okay, so there's only one current flowing here, which is here is I1, here is I2. But for this 2 ohm, there are two currents flowing there. We have I1 and I3. So the polarities there is plus and minus, and then this is plus and minus. So there's a current flowing in this direction, which is I3. There's also another current flowing in opposite direction, which is I1. So if you look at it closely, you see that on this 2 ohm resistor, the current is flowing to the left, which is I1. The same I1 is flowing to the right in the form resistor. So that's how it is when it is going like this. So let me just do it when it is going in clockwise direction. So if you had to, this is a circle like this, but if you had to use it like a box, it is like this. So it now depends on where the element lies. So it's now determine if it is to the right, downward, left, or upward. I hope that is clear. Alright, so let's do the same thing for the 6 ohm resistor. So we have plus and minus, the same thing here, and then plus and minus. So we have a current flowing in this direction, which is I4. We also have another one flowing in this direction, which is I2. Alright, so that's it there. So please, I want you to, for this particular example, if you are just watching without taking notes, please, I want you to take notes, because I'm going to be cleaning up something just to manage space. So I want you to be taking notes alongside, and then you pay attention to this. And if in the process, if you have any question, you can just leave them in the comment section below. I do read my comments and give replies to every comment I receive. Alright. Alright, so this SuperMesh circuit, now let's apply KVL. To SuperMesh circuit. Alright, so let me just start from this point, and then I'll go around the circuit. So the first element we are having here is the 4 ohm resistor. So the current passing through it is just I1, so which is from plus to minus. So that's going to be minus 4I1. So from there we go to the 8 ohm. From plus to minus, that's going to be minus 8I2. The current there is I2. Come down, we come here, and then from plus to minus, so that's going to be minus, and then that's I2, minus 6I2. Don't forget, I'm dealing with the 6 ohm resistor. And from minus to plus, due to current I4, so that's going to be plus 6I4. And then from plus to minus, 2 ohm resistor. Now we need 2 ohm resistor. The current there is I1. That's from plus to minus, so that's going to be minus 2I1. Then from minus to plus, due to I3, that will be plus 2I3 equals to 0. Alright, so this now let's just rearrange this. So let's start from I1. This is I1 here. This is another I1. So that's going to be minus 6I1. So what about I2? This is I2. So okay, so that's going to be minus 14I2. So what about I3? I3, there's only one I3, that's plus 2 I3. What about I4? So this is I4, that's plus 6 I4 equals to 0, and this is our equation 2. So I believe all is good. Minus 6 I1 minus 14 I2 plus 2 I3 plus 6 I4 equals to 0. That's equation 2. Alright, so that's been done. So the next thing we are going to do is this mesh 3 and 4. So this is that we have our I3 and our I4 here. So let's call this mesh 3 and let's call this mesh 4. Alright, so let me just draw a line so that I can just create some kind of demarcation. So that let's work with mesh 3. So let's write apply KVL to mesh 3. So for mesh 3 now, where we are having I3, we're also going to apply KVL. So we go around this particular mesh. So let me start from this point. So we'll go around like this, and then we'll come back to where we started from. Alright, so the first element I'm coming across on this particular mesh is this 2 ohm resistor. So let's do the same thing. So from negative to positive, and because of current I1, you can see that's current I1, that's why I post negative. Why from positive from negative to positive due to current I1, while from positive to negative is I3. So you have to be careful with some of these things so that you don't just make mistakes, because one thing about all of these things is once you make a mistake in a particular sign where you have positive and you put negative, then you're going to get a totally different answers. Alright, so let's continue, or let's start with mesh 3. So negative to positive, the 2 ohm resistor due to I1, so we are going to be having 2 I1. So from positive to negative, so that's going to be -2, and this time around I3. So let's come to this. So this is from plus to minus due to I3, so that's going to be -3 I3. That's because this is the 3 ohm resistor. So also from negative to positive due to I4, so that's going to be plus 3 I4. So when we continue like this, here right here we also have another element which is a voltage source. We're also going to include it. This is negative to positive, which is plus 30 volts equals to 0. I'm just keeping the volts so that it will not affect our calculations. Now you also know that this is already in volts already, because all of these things are in volts. This 2 represents a resistor which is R. This is a current I. This is to give us volts. From V is equals to IR, Ohm's law. So all of these things are volts. This 3 is already in ohms. This I is in current, but we don't know the values. That's why we are having I3, I4, I1, I2. I hope that is clear. So this 30 is already in volts, so we just put it like that, 30. They can all stay together. So let's simplify this. So I1, so we're having 2 I1. So what else? Is there any I2? It seems there's no I2 here. So let's go to I3. So we are having -2 -3, that will be -5. -5 I3, then plus 3 I4, and then this 30, let's take it to the other side of the equals to time, it becomes -30. Yeah. And this is our equation 3. So we are not done yet. So this is -2 I1 -5 I3 plus 3 I4 equals to -30. This is our equation 3. So what we've done to mesh 3, we are going to do the same thing to mesh 4. So because of space, let me just create some space at the top. Alright, so let's continue now. Let's do that of mesh 4. So for mesh 4, this mesh, we are going to, let's also start from this point and then we go around the mesh. So from here, so this seems ohm resistor from negative to positive, so that'll be due to current I2, so that'll be 6 I2. Also from positive to negative, that'll be -6, and this time around it is due to I4. So that's it for the 6 ohm. Now let's come to the 1 ohm resistor. So from positive to negative, that's -1 I4. And then let's come to the 3 ohm resistor. So we'll continue like that. So from positive to negative, that's -3 I4. While from negative to positive is due to I3, due to the current I3. So that will be plus 3 I3 equals to 0. So let's rearrange this. So this will be, let's see, we have I2. So there's no I1 here. So we have I2. Let's see which other I2. That's only I2. So we have 6 I2. We have I3. We have only one I3. That's plus 3 I3. And then I4, we have -6, -1, and -3. So that's -10. -10 I4 equals to 0. So this is our equation 4. So let me write it here. 6 I2 plus 3 I3 minus 10 I4 equals to 0. So this is our equation 4. So I can go ahead and then rub this off so that we can have enough space to solve these questions. So now at this stage, what we are going to do is we are going to do some substitution so that we can reduce these equations into 3, such that with that we are still going to get I1, I2, I3, and I4. So that's why I said this particular example is different from the previous ones that we are looking at. So we have 4 currents that we are actually looking for, because we are having four meshes. So for us to do that, for us to simplify it now from this equation 1, so let me write it here, that from equation 1, so from this equation 1 we can take it as I2 equals to 4 plus I1. Are you following? So where we have I2 equals to 4 plus I1. So what we are going to do is we are going to substitute I2 equals to 4 plus I1 into equation 4. So what this means is that anywhere we see I2 in this equation 4, we are going to replace it with 4 plus I1. So this is it. So this is the only place we are having I2. So what I'm doing now is just a normal basic math. So don't let it to confuse you. I'm not doing any magic here. Alright, so that would be 6 into bracket. So I2 is here is this I2, we are going to replace it with 4 plus I1. 4 plus I1 is just a way to simplify the different equations. Then plus 3I3 minus 10I4 equals to 0. So this will give us 24 plus 6I1 plus 3I3 minus 10I4 equals to 0. So if we should rearrange this, we are going to be having 6I1 and then plus 3I3 minus 10I4 equals to minus 24. So let's call this equation 5. Are we following? Alright, so let's continue. So what we've done to equation, so let me just create some little demarcation so that I don't just get everything mixed up. So what we've done here, whereby we substitute the value of I2. I hope you remember we got this I2 is equals to 4 plus I1. That is from here. We just made I2 the subject formula. So that made it 4 plus I1. So right here we substitute the value of I2 into equation 4. So what we did here, we are also going to do it to equation 2. So we are going to substitute I2 equals to 4 plus I1 into equation 2. So this is equation 2 right here. So this is where we are having I2. This is the place we are having I2. So in place of I2, we are going to put 4 plus I1. So we are going to be having minus 6I1 minus 14 into brackets. Now instead of having I2, we put this value 4 plus I1 plus 2I3 plus 6I4 equals to 0. So that is minus 6I1 and then minus, so 14 multiplied by 4, that will give us 56, minus 56, then minus 14I1. So if you are still following, please give the video a thumbs up so I know that you are still following at this point. Then plus 2I3 plus 6I4 equals to 0. Alright, so let's just do some rearrangement here. Let's just rearrange everything so that it can look neat. So we're having minus 6I1 and then minus 14I1. So that will give us minus 20I1. So let's see if I3, we are having 2I3. So that will be plus 2I3. And then for I4, okay, this is the only I4 we have here. That's plus 6I4. Then equals to, now we're having 56 here. If you bring it to the other side of the equals to sign, it becomes, this minus 56, it becomes 56. So this will take it as our equation 6. Alright, so now let's look at it closely. At this point now, so let me just draw a line here, just to create some demarcations. Alright, so now what we'll do here is, we are going to solve. So, remember in the previous example, naturally we'll just have equation 1, 2, and 3, and then we'll solve it simultaneously, and then we get an answer. So right now, since we are having 6 equations, we only need 3, and the 3 equations that will give us the value of I1, I2, and I3, and I4 is that's equation 3, 5, and 6. This equation 3. So solve equation 3, 5, and 6 simultaneously. So if you solve those 3 equations, that is equation 3, equation 5, and equation 6. So once we solve those equations simultaneously, we'll get I1, I3, and I4. Because if you look at those 3 equations, you can see that you have only I1, I3, and I4 in equation 3. Equation 5, I1, I3, I4. Equation 6, I1, I3, I4. So that alone, once we solve those 3 simultaneously, we'll be able to get I1, I3, and I4. and then we can use it to now get which other one that is missing, I2. So let's quickly do that. So you might want to write this down before I just clean it off because of space. Alright, so if you solve those three equations, equation 3, 5 and 6 simultaneously, you're going to get your I1 to be minus 0.553 amperes, you're going to get your I3 to be 8.561 amperes, and your I4 to be 4.636 amperes. So the reason why I didn't show it is just to save time, and then I've also demonstrated it in the last two examples how to do that with your calculator. So I want to believe you're able to get that concept, or you can even solve it using substitution or elimination method. But whichever way, this is what you're going to get: I1, I3 and I4. But now we don't have I2, so but with these values we can use it to get I2. So that's why I left this particular equation 1. So what we just do is, let's get that. So from here we know that our I2 is what? 4 plus I1. That is from here. Once we bring the I1 to the other side, we make I2 subject of the formula, we are going to get this. So with that, we are going to be having 4 plus our I1. We've gotten our I1 to be minus 0.553. So that will be plus minus 0.553. So once you do this, you are going to, it's just the same thing as 4 minus, this is plus and minus this, which is going to be minus. So that's going to be 4 minus 0.553. So that will give us 3.447 amperes, which is our I2. Our I2. So with what we are having here, we've been able to get the currents in each of these meshes. That is I1, I2, I3 and I4. This is it. So this is our I1, this is our I2, this is our I3, this is our I4. But that's not the end. So the question also asks us to find the current passing through what? Each of the elements. So we have, how many elements do we have here? 1, 2, 3, 4, 5, 6. We have 6 elements here. That means if these resistors, they are what we refer to as elements. So let's go ahead and start to calculate the current that is flowing through each of those elements. So let's just take it from the top and then we come down. Now let's start from the 4 ohm resistor. So that means the current, so that's I, and then with a subscript of 4 ohms. So that means current in the 4 ohm resistor. Now let's look at it again. Now in this 4 ohm resistor, we only have one current that is flowing through it. We have only one current, and that is I1. So that means the current flowing through the 4 ohm resistor is just I1, and the value for we've got for I1 is what? Minus 0.553 amperes. Now if you look at this thing now, we are having a negative value as our current. Now whenever you have a negative value for current, that means whatever direction you assumed that gave you that answer is not the actual direction. That means it's supposed to be the opposite direction. So what we are going to do is that, so for us to now get the real value that should be in positive, we are going to do this. So that means the answer is what? 0.553 amperes. Now remember that the direction that we picked that gave us this negative was the clockwise direction. That means we assume that the current is flowing in this direction. Look at it, clockwise. It's going like this, in this direction. So that means this is not the actual direction, but what's in opposite, that means it's like this. So you can put this in brackets. Exactly. So once you can see, this is the correct direction that the current is flowing. So that's why we are not having the negative. I hope that is clear. This is the direction. So that is it. We've been able to get the current that is flowing through the 4 ohm resistor to be 0.553 amperes in this direction. So now let's look at the next one. The current flowing through the 8 ohm resistor. There is only one current flowing through this 8 ohm resistor, and that is I2. And let's look here. The current flowing through it is what? 3.447 amperes. So you can see that this is a positive answer. It's giving us a positive value. That means the direction we assume here, which is like this, is actually the direction that the current is flowing. So that means the current is actually flowing in this direction. So that's why it's positive. So now let's look at the next one. So the next one we want to consider is this 2 ohm resistor. So that's the current flowing in the 2 ohm resistor. So if you look at the 2 ohm resistor, there are 2 currents that are flowing in that particular resistor. We have I1 flowing, and we also have I3 flowing. So if you look at it, I1 is flowing in this direction, and I3 is also flowing in what? In this direction. So for us to now get the current that is flowing through it. So let's look at it. I3, this is I3, and then this is where is I1, and then and I1. So what you do is you pick, since we know that I3 is 8.56 and then I1 is minus 0.553, so you pick the one with the higher value. So the one with the higher value is what? Is I3. So that will be I3 minus I1. So whatever we get here will give us the actual current that is flowing through the 2 ohm resistor. So that will be what? I3 is 8.561 amperes minus 0.553 amperes. So when we do that, that will give us 9.114 amperes. Now for you to get the direction, we are going to pick the direction of the one that is coming first, the one with the higher value, which is I3. So I3, the direction for I3, which is the higher value, that's the one that is actually also coming first. So that's how you used to know, like this. So this will be the direction. So most times when you solve these things and you add your direction, is just let the person, whoever is going through it, to know that yes, you really understand what you are doing. So let's do that of the 6 ohm resistor. So let's, the current through the 6 ohm resistor. So there are also 2 currents flowing through it. We have the 2 I2 and then I4. So let's look at I2 and I4. This is I2, 3, and then I4. Which one is higher? I4 is higher than I2. So that means we are going to be having what? I4 minus I2. So which will be 4.636 amperes minus 3.447 amperes. And that will give us what? So that will give us 1.189 amperes. And don't forget the direction will be what? Direction of I4, because I4 is higher than I2. So if you look at the direction of I4, the direction that it is having when we are looking at it at the 6 ohm resistor, you see that it is towards this direction. So let's look at the next one. So okay, that's the last one. That is the 1 ohm resistor. Okay, we still have 3 ohm resistor here. Alright, so let's look at the 1 ohm resistor. So there's only one current that is flowing through it, which is I4, which is only I4. So that means this is still going to be I4, and that is 4.636 amperes, and the direction is downward. That this one is straightforward, is downward. So now let's look at that of the 3 ohm, which is the last one. So if I want to just pause the video and attempt this based on what I've explained here. So there are 2 currents flowing through it, which is I4 and I3. So let's look at it, I4 and I3. So we can see that I3 is higher than I4. So we are going to be having, so the current flowing through this 3 ohm resistor will be what? I3 minus I4. So which will be 8.561 minus 4.636 amperes. And that will give us 3.925 rather. 925 amperes. And the direction will be what? The direction of I3. So direction of I3, since I3 is higher than I4, so it will be downward. So in downward. So that will be the direction. So let's look at the last. Is that all? 1, 2, 3, 4, 5, 6. All right. So that's it. So with this now, we've been able to answer this question. We've been able to get the currents that is flowing through each of these mesh, which is I1, I2, I3, and I4. We've gotten the value. This is I1, this is I2, this is I3, this is I4. We've also gotten the current that is flowing through each of the elements. So when they say each of the elements, those are the things that you have in there. So like the resistor, this voltage source, we already gotten the current that is flowing through. Basically, the one we are more interested in is in the resistor. So we've gotten the currents through the 4 ohm resistor, the 8 ohm resistor, the 2 ohm, 3, 1, and the 6 ohm resistor. So whatever we have done here are the steps on how to go about it. So if you find value in this video, please give it a thumbs up. This is a very long one, and I want to, if you watch this to the end, I want to say a very big thank you to you, and I hope you find value. If you do, please give it a thumbs up. And if you are yet to subscribe to PE Academy, please subscribe. There's still one more example that I want to share with you. So I want to encourage you, don't miss that one example. The last one, that's example 5. And if you have any question concerning this, do leave them in the comment section below. Please share this video, like, subscribe, and I'll see you all in the next video. Thank you.